Hi guys, welcome back to the channel. So in today's video we're going to be solving this question. So we are given that the sketch below shows a pyramid on a square base. So we have a square base. That means already we can see that in a square, if this length is 10, then this one will also be 10. All the length are equal, the side of the length of the square are equal. So the length of the side of the base is 10 centimeter. The perpendicular height of the pyramid is 15. That means the perpendicular height is somewhere there. Maybe we can put it like that. The height that is perpendicular, we are given that it's 15 centimeters, right? So the first question, okay, we are also given the formula for volume of the pyramid given by 1/3 multiplied by area of the base multiplied by the perpendicular height, and we are also given the total surface area of the pyramid is equal to area of the base plus sum of areas of the triangular faces. Okay, let's do it then and see. So the first question we are given that 6.1.1, they are asking us to calculate the volume of the pyramid, right? So the volume of the pyramid, we are given that the volume of the pyramid, I will just write VP is equals to, which is the volume of the pyramid is equals to 1/3 multiplied by area of the base. Area of the base in this case is going to be 10 multiplied by 10 because area of the square is given by height multiplied by that, the length of that. Then it's going to be this 10 multiplied by this 10 multiplied by then the perpendicular height, which is going to be perpendicular height. We are given that it's 15 centimeter. So it's equal to, this is going to be centimeter square, this is centimeter. Then because it's the volume, obviously at the end we are going to have something like 1 over, instead of 1/3, let me just simplify it. It's going to be 1/3 multiplied by 15, it's 5, multiplied by 100, which is equals to 500 centimeter cubed. Going to be cubed, right? So that is the answer for the first question. That is the volume of the pyramid. So 6.1.2 6.1.2, they say calculate the total surface area of the pyramid, right? The total surface area of the pyramid is given by area of the base. So we have to calculate area of the base. Then after calculating area of the base, then sum of areas of triangular faces, right? Area of the base, we already know it. Area of the base, it's going to be 100. That is area of this base, it's 100. Then we have to find area of each triangle, right? So to find area of each triangle, the first thing that we have to do, we have to calculate the slant height. The slant height is equals to, remember the slant height is going to be, here you can draw like we have the perpendicular, then you draw this, then this. We want this height here, this slight height, which goes on to each and every triangle like that, right? So to calculate that, you're going to say we can use theorem of Pythagoras, because they said the perpendicular height of the pyramid is 15. So we have 15 here, and obviously because it's perpendicular, that means it cuts the square into half, and we know that this is 10. So when you cut this into half, it's going to be 5. We're going to have 5. So we'll have something like this being 5, this being 10, because it's perpendicular 90 degrees. So we want to calculate this slight height, this one. So we know that we can use theorem of Pythagoras to do that. Then we're going to have the square root of 10, not 10, square root of, this is 15, I'm sorry about that. It's going to be 15 squared plus 5 squared, right? Which is equals to, when you put it on your calculator, you'll find this is 250. 250 square root will be 5 into 10, right? 5 into 10 causes 25 times 10. 25 times 10 is 250. So 10, we leave it inside 5. Then 25 squared is going to be 5. Then we have this, right? This is the length of this, the height of that. Then obviously total surface area, this is total surface area, is given by area of the base, remember it's 100, plus sum of areas of the triangular faces. So obviously area of triangular faces, how many triangular faces do we have here? 1, 2, 3. You can see it's this side, that side, that side. It's 4. Then it's going to be, some of those will be 4 into area of triangle. So area of triangle, we know that it's given by, you have to know area of the triangle. The formula is 1/2 multiplied by, it will be 10. It's half multiplied by 10 multiplied by 5 into 10. That is the formula for that. So we are taking this for a triangle. We take this, then we take the slant height, we multiply both of them then by half. So it's going to be 100 plus 4 into this. It's going to be 4 into 5 multiplied by the square root of 10, 5, right? So when you simplify this, you can see that this will be 20, this will be, then we're going to have 416.23 centimeter cubed for this question. I hope you understand it, how I got into this, but there's no, I cannot say it's tricky. You just have to calculate the slant height, then after that they give you the formula for this, then you just do it how they give it to you. Then let's do the last question. The last question, they are saying a child is given some modeling clay to play with, right? Modeling clay to play with. At first, he uses all the clay to make a single sphere ball, right? Thereafter, he uses all the clay to make identical smaller spheres. If the diameter of each of the smaller sphere is exactly half, it's half the diameter of the original sphere, how many smaller sphere will he be able to make, right? We are given the volume, we are given the total surface area of the sphere. So obviously the first thing that you have to note down, we can say let, I'm solving 6.3, let r, which is going to be obviously the radius because it's in half. So the radius, we can say single sphere. Let's just say, to make it simple, single sphere, if it's r, and obviously if it's r, the one for smaller sphere, let's say smaller one, smaller sphere will be how much? Half. Remember, we said it's half. Thereafter, a child is given some clay to play. At first, he uses all the clay to make a single ball, which is this one, right? Let's say this is equals to r. This is equals to r. Then the second one is going to be half of this, right? Thereafter, he uses all the clay to make identical smaller sphere. If the diameter of each of the smaller sphere is exactly half, you see this is the diameter. This is the first one, the diameter, which is r, then the other ones are half. It's exactly half the diameter of the original, hence we put half here. How many sphere will he be able to make, right? So to do that, then after, you can just say, then let's calculate the volume of this big sphere, single sphere. Let's say volume of single sphere is given by, what will be the answer? The volume, obviously it's 4/3 pi into, we have to substitute that, which is r. In this case, we used r. Then it's just going to be 4/3 pi r squared cubed, right? We're going to have that. Then after that, let's calculate and the volume of this one smaller sphere is equals to, then we use the same formula, then it's pi into, where we see that we're going to put 1/2r cubed. Then this, solving this, simplifying this, obviously we're going to have 4/3 into this was going to be 1/8r cubed, right? Then simplify this, obviously you can have 1/8 into 4/3 cubed r, this. So the reason I put it like this is because, as you can see, we have this, which is the same as this, right? So the only thing, the question here they're asking us, how many smaller sphere will we be able to make? Already you can see this will be the answer, right? So you can just say, since this is the same, but we multiply this by 1 over 8, then you can just say, therefore, 8 smaller, going to be 8, right? It's 1 over 8. 8 smaller sphere can be made using the same modeling clay. I'm going to explain why 8, right? Modeling clay. So that is the answer. You are done here. So the reason we say 8 is because if you want these two to be equal, you have to multiply this by 8. You have to multiply by 8 because 8 multiplied by 1 over 8 is going to give you 1, which is going to be 1 multiplied by this, which is going to be the same as this here. So for you to get that, you must get 8 smaller sphere can be made using the same modeling clay. So basically that is the final answer. Thank you for joining me, guys. Let's move to the next question.